Let's take a look at solving equations. So today we're going to look at equations involving collecting like terms, so combining variables together, and then also what happens when we have brackets, so potentially using the distributive property where we can expand those brackets out. So just a reminder from what we've done before with solving equations, one of our techniques was to use opposite operations. So essentially, to rearrange the equation, you move the one part over to the other side, and you move it over by basically switching whatever operation it is to the exact opposite. So for example, in these mini examples, you have an x plus 8. So we want to move this plus 8 to isolate that variable x. And what's the opposite of adding 8? Well, the opposite of adding 8 is subtracting 8. And so then that's going to leave us with an answer of 17 minus 8, which is just going to be 9. What if you're doing something like division here on the right-hand side? So if you're dividing by 5, so you have a divided by 5, because a fraction is just division. Well, if you move it over to the other side, the opposite of division is multiplying by 5, so I'll do times 5. And so that gives us a is equal to, in this case, 30 times 5 is 150. And we're going to be making use of that opposite operations throughout this lesson. All right, so let's just start off with a couple of more simple examples, and we'll build things up as we go through. So we have 5x minus 8. So what we want to do is we want to first of all move things over. So we want to isolate the x, and we want to isolate the parts that are added or subtracted to it first. So you'll see there's a 5 in front of it. That's being multiplied. But this minus 8, that's what we want to move over first. So let's deal with that minus 8 first. Since it's subtract 8 there, the opposite is going to be plus 8. And so we're going to have 5x is equal to, well, 12 plus 8. So that's going to be 20 now. Okay. The next step is now we can deal with the 5. So the 5, right now we have this statement that says 5 times x. So if we want to move it over, well, to move it over, we need to divide the right-hand side by 5. So x is going to be, I'll write it as a fraction, 20 divided by 5, which is just 4. And there we've divided, or we've solved for x. All right. Now let's move on over to b. Now, b is going to look a little different, because we have x, 7x there, but we also have another area where there is x. So how do we solve for x? So whenever we have two x's, as in some term with x on one side, some term with x on another side, we're going to have to move one of our terms with x over to the other side. So move one of your terms with x, I'll just write this above, to the other side. So all our x's are on the same side. And this will be key. Okay, so let's take a look at this. So if we want to move one of our x's, what I'm going to do is I'm going to move this term that's 2x. And this is where we need to be careful, because right now you might be thinking, oh, there's a 2 in front, we're multiplying by 2. Do we divide by 2x to move it to the other side? But what's happening here is we're actually, since we're moving this entire thing, so both the 2 and the x, we can think of this entire thing as, well, since there's no number in front of it, we can think of it, or there's no sign in front of it, we can think of it as something positive. So if we move it over, we're going to move it over to the left. And so we're going to subtract it from the left-hand side. So what's going to happen is, on the left-hand side, we now have 7x minus 3. We're moving over that 2x term on the right, so we're subtracting 2x. And that means now on the right-hand side, we're just left with a 3. Okay, so now that we have our terms with x all on the same side, we need to collect these two terms that both contain x. So collect like terms. But we can only do that when they're on the same side of the equation. So if we collect like terms, we have 7x, and don't forget about the sign in front of the 2, so minus 2x. Together, that makes 5x, since 7 minus 2 is 5. And then 7x, or 5x minus 3 equals 3 now. All right, once we get it down to this stage, we are simply solving this like we would something like an A. So we're going to use opposite operations and isolate for x. So we have a minus 3 here, so we're going to move that to the other side. That's going to become a plus 3. So 5x equals 3 plus 3, which is 6. Next, we have this 5x, so we have 5 times x. So we want to move the 5 over. Well, to move the 5 over, we divide by 5, since it's originally multiplication. So you have 6 over 5, since that's division. And we can just leave it as that. So if you have a fraction as your answer, that's totally okay. Just leave your answer as a fraction. No need to turn it into a decimal. All right, let's take a look at some of these other ones where you can collect the terms as we just did. Okay, so in this next one, we have a minus 2t and a minus 5t. So sometimes the question might be, which way should I move the t's? Should I move the minus 2t to the right-hand side? Should I move the minus 5t to the left-hand side? In the end, it doesn't actually matter. If you use proper solving steps, you will get the same answer. What I will do, though, is in terms of just keeping things neat, I always like to move things over to the bigger number. So let's compare negative 2 and negative 5. Since negative 2 is bigger than negative 5, because it's negatives, so even though negative 5, the 5 looks bigger, it's actually further on the left-hand side of the number line. So what I like to do is I like to move things over to the bigger side. And the reason being is that as you start to solve things, it'll keep things as positive numbers when you move it over like that, which I'm sure we all like better than dealing with negatives. Okay, so we're moving over that minus 5t. So if we move over negative 5t, well, that's going to become plus 5t. So let's rewrite that. So we're going to have 3 minus 2t plus 5t equal to, well, just 5, since we moved that term over. Now, let's collect the like terms. So we've minus 2t, don't forget about the sign in front, plus 5t. And combining those two, minus 2 and 5, well, that's plus 3. So we're going to have plus 3t is equal to 5. And if you'd moved it to the other side, you would have gotten a negative number, but in this case, we got a nice positive 3t. All right, next we need to move the number that's sort of just not attached to our t over, first of all. This number in front is a positive number, so it's going to turn into a negative, so it's going to be minus 3 on the right-hand side. So 3t is going to equal to 5 minus 3, which is just 2. Next, take that 3, move it over. It's 3 times t, so we got to turn it into division, and that will leave us with an answer of 2 over 3. So again, we're using opposite operations throughout all of this solving equations part. All right, this example D. Now this one looks like a tricky one. You have an x in the denominator. What on earth are we gonna do here? So what we can do here is, if you have a variable in the denominator, I'm just going to go to the next line. What you can do is you can just multiply the entire equation by that variable. So we'll see what I mean by that. Because in a sense, we don't want to have a variable in the denominator. So it's going to allow us to get rid of that denominator. So multiply the entire equation by x, or by the variable. Okay, so let's see what we mean by that. So in this case, we have x, so multiply all by x. So we're going to have negative 2, multiply that by x, plus, 4 over x times x equal to 17 times x. So literally every single part we're multiplying by x. And the reason we're doing that is our fraction is going to disappear because of that. Because if we have something like 4x over x here, that's what 4 over x times x equals. Well, x and x will cancel out. And so now let's just rewrite the equation. So we've now turned the equation into negative 2x plus, there's just a 4 left here, equal to 17x. And that's much more reasonable to be able to solve. You don't have to worry about a variable in the denominator. So now, like the previous ones, when we have x's on multiple sides, bring one of your x's over to the other side. So what I'm going to do is I'm going to bring this negative 2x over to the right-hand side. I'm moving it over to the bigger number. So 17 is bigger than negative 2. And that will become plus 2x. So let's just rewrite that as 4 equal to 17x plus 2x. And then combine like terms. So you have a 17 and a 2x. So that'll become 19x. I'll just write that on the side here, collect like terms. And we're very nearly done. We've 19 times x. So we need to move the 19 over. Divide by 19, that means. And what does that mean? Well, you have 4 over 19 on the left-hand side is equal to x. And it's okay if you solve it on the right-hand side. That's still the same as just saying x equal to 4 over 19. You can always just switch or flip equations, as in flip the left and the right-hand side. So you don't have to feel like you always have to have your missing variable on the left-hand side. All right, what do we do when we get to things with brackets? There's a couple ways we could do this. What we're going to do is we're going to make use of the distributive property throughout these parts. So remember the distributive property or distributive law is how we expand out brackets, is what we called it. And it basically said something like, if you had 2 times a number in brackets, well, you took that 2, you multiplied it by both of the parts in the brackets. So you did something like 2 times a minus 2 times 3, which would be 2a minus 6. And that's what we're going to do when we solve this equation. So take this number, the left side, that's what I did there. So 2 times a times 2 times 3, which is going to be 2a minus 6, And do the same thing with 3 times a, 3 times 1. So it'll be 3a minus 3, because 3 times 1 is 3. And we have the minus signs because that's coming from inside of the brackets. All right, now like we did the previous page of questions, what you're going to do is move one of your sets of a to the other side so they're all on the same side. So I'm going to move the 2a to the right-hand side. So to move it to the right-hand side, positive 2a is going to turn into negative 2a, which is the same as just subtracting by 2a. And so on the left-hand side, we just have the minus 6 or negative 6 is equal to 3a minus 3 minus 2a. All right. Next, we need to collect the like terms. So we have a 3a and we have a 2a. The 3a is positive and we're subtracting the 2a, so what we're left with is just a single a. And then you still have that minus 3 beside it. All right, and then you have negative 6 still on the left-hand side. All right, continuing along, now we can finally get to use opposite operations for figuring out what a is actually equal to. So we have this minus 3 at the end. So when we move it over to the left-hand side, we're adding 3 to the left-hand side. So it's going to be negative 6 plus 3 is equal to a. What's negative 6 plus 3? Well, negative 6 plus 3 is equal to negative 3. So negative 3 is equal to a, which is just the same as saying a is equal to negative 3. So again, as I said before, it doesn't matter if you have it on the left or the right-hand side, your variable. All right, let's take a look at this next example. So if you can, try it out yourself first. Maybe pause the video, but I'll just go straight through it. But don't hesitate to pause it. Try it out yourself with all of the upcoming examples. So we start off with doing the distributive property. Again, remember when you're doing the distributive property, you only multiply by the parts inside the brackets. So the negative 3 only goes with the y and the 2. So you're going to have negative 3y plus negative 3 times 2. We'll simplify things in just a moment, but we'll start with that. On the right-hand side, you include the sign, so don't forget about the negative sign in front of there, just like we did with negative 3. So negative 4 times y. And then minus negative 4 times 1. And the minus sign just came from the fact that there's a minus sign in the brackets. All right, so what does that mean? We have negative 3y. Negative 3 times 2, well, that's negative 6. And if we're adding a negative number, that's the same as just saying minus 6. All right. On the right-hand side here, negative 4 times 1, well, that's just negative 4. If we're subtracting a negative number, well, that's the same as adding 4. So we're making use of just changing our double signs into a single sign. Okay, so now we're at the stage where we need to decide which side to move our variables over. Again, there's no one correct side. You can do it to either side. I'm going to move over to the left-hand side, the negative 4y. I'm choosing to move it towards the bigger number. So negative 3 is bigger than negative 4. And moving it over, negative 4y will turn it into plus 4y. So let's rewrite things. So we're going to have negative 3y minus 6 plus 4y is equal to, since we moved it over, we just have a plus 4, which is just the same as just saying 4. So you don't actually need to include the positive once you move it over. All right, next we collect the like terms. So what's negative 3y combined with positive 4y? Well, negative 3 plus 4 is just equal to y. And then we still have the minus 6 left over. is equal to 4. Then take that minus 6. We're moving it over to the right-hand side. So we're changing it to a plus 6. Again, using opposite operations. 4 plus 6 will give us 10. And so there we have it. We've used the distributive property, expanded things out, moved our variable over to the other side, collected like terms, and then used opposite operations at the end there to get our final answer. Let's look at a couple more, just for good measure. All right, in this next one, again, we use distributive property. So 7z, 7 times 3. So let's write that down. 7z plus 7 times 3. What's that going to equal? Well, on the right-hand side here, we have a 5 in front of the bracket, so 5z and 5 times 1. So 5z minus 5 times 1. So let's simplify things. We still have 7z plus 7 times 3 is 21. 5z minus 5. All right, again, what I'll do is I'll move the smaller z term to the side of the bigger z term. So since we have 7z on the left, I'll move 5z over. So it's going to turn into a negative when we move it over. So we have 7z plus 21 minus 5z. And that's going to equal negative 5. All right, next, collect the like terms. All right. And that's going to mean, again, when we're looking for like terms, you're always looking for where are the variables, are they identical? So z and z are identical. Don't forget about the sign in front. So 7z minus 5z. So 7 minus 5 is just 2z's left over. We have a plus 21 is equal to negative 5. All right, now, like we've done these previous solving equation questions, we need to move the part that's being added or subtracted over first. So the plus 21 turns into a minus 21. That will give us negative 5 minus 21 is negative 26. Then the 2 that's in front of the z, since that's being multiplied, it turns into division. So divide by 2. Let's just finish off the question here to the right. So since we moved over the 2, it's just going to be z left over on the left-hand side. Is equal to negative 26 over 2, or divided by 2. And since that's a fraction, we can reduce that fraction. That divides nicely down to negative 13. And so there is our final answer. All right, let's take a look at one last example. It's a little bit of a bigger one, but we're going to use the concepts that we've been using from before. So to begin, we have a whole bunch of brackets. Let's just use distributive property on those brackets. So we have 3 times n. And then 3 times 1. 3 times 1 is just going to be 3, so we're just going to have minus 3. Let's leave the plus 12 there. All right, 6n is there. Then we have minus 3, 5 minus n. So what are we going to do here? Well, we're going to have minus 3 times 5. And then we are going to have, so we did this multiplication with the minus sign. So don't forget about that minus sign. And then we also have, we're subtracting the last part, but we're going to have minus 3 times that n. So let's just pay careful attention to the negative signs there. That is easy to accidentally make a small mistake with. Okay. So 6n, what I'll do is, let's multiply 3 and 5. That'll give us 15. We have a minus sign in front, so it's just going to be minus 15. In this next case, we had a minus sign here coming from inside of the brackets, but we were also had another minus sign coming from the number in front, since we were subtracting this entire set. So that's why we have both this and this minus sign. And so because of that, oops, I erased that, the double negatives there, that's going to turn into a plus. So you're going to have plus, in this case, 3n. All right, so you might be wondering, what do we do next? We have many n's and all sorts of terms all over the place. So at this stage, we could clean up the left and the right-hand side. And by clean up, I just mean collect terms on the individual sides, So, for example, on the left-hand side, we have some numbers. So you have a negative 3 and a 12. You could combine those together. So let's do that. And we'll just leave the 3n as is. So we have 3n minus 3 plus 12. So minus 3 plus 12 is going to be plus 9. And then let's look for like terms on the right-hand side. So I'm going to do this in a different color. So you have a variable, 6n. You also have another variable, 3n. Those two are like variables. So we can combine those on this side. And together 6 plus 3, well, that will just give you 9n. And the 15, well, that's just, there's nothing to combine it with on that right-hand side, so we'll just leave it as minus 15. Okay. So now we can solve this out like we've done the other ones. So move over one of your terms, so the 3n in this case, to the right-hand side is what I'm going to do. That's going to turn into minus 3n. So 9n minus 15 minus 3n. Then let's combine like terms on the right-hand side. So in this case, we have to collect like terms multiple times, but that's okay. Sometimes these questions will take multiple collecting steps. So on the left, we still have a 9. On the right, 9n minus 3n. Well, 9 minus 3 is just 6. So we just have 6n minus 15. All right. Now what we're going to do is this minus 15. That moves over to the left-hand side. So we're moving the plus or the minus part first, and then we will move the number attached to the variable afterwards. So plus 15 is what that's going to turn into. So we will rewrite this over here. So this is going to turn into 9 plus 15, which is equal to 6n. 9 plus 15, that's just 24. So 6n is equal to 24. Then the last step, we have 6 multiplied by n. So that 6 is multiplied. So when we move it over, it's going to be divide, since division is the opposite of multiplication. So you're going to have 24 over 6 is equal to our variable n. Reducing that, that gives you 4 is equal to n. And that is the end of that particular problem and the lesson as a whole.